Joining us now is Ron Stevens. Ron is president and CEO of VOTAN. And Ron, we have a new piece of equipment up here now. Tell us what this is.
This box is the VOTAN V5000. It provides speech recognition and voice compression and playback facilities. It's connected over an RS-232 line with this IBM personal computer. And this is the color monitor that we have substituted for purposes of this demonstration for the normal monitor associated with the IBM PC.
Okay, run through a demonstration now and show us what this VOTAN unit does.
All right, the software package that's resident in the IBM PC is controlling this monitor, and I am going to illustrate the substitution of a microphone and my voice for the keyboard. So I'm going to control this program through the V5000 into the IBM PC and up to the screen with the microphone. Executive? Executive? Sales?
Which product line, standard or deluxe?
Deluxe?
What channel, OEM, distribution, or total?
Total?
Would you like to compare to last year?
Yes.
Would you like to forecast for next year?
Yes.
We'll use 2 digits to indicate percentage growth over this year. Say the first digit.
2.
Say the second digit.
5.
The boss will never believe that. Let's keep it under 20%. Say the first digit.
1.
Say the second digit.
9. Exit. Exit. Telephone.
Who should I call?
Stockbroker.
Dialing.
There's a
Good
comment.
afternoon, ABC Brokerage. This is our computer information lookup system. You will be able to access information about your account by voice. At the sound of the tone, please enter your 3-digit access code, 1 digit at a time.
3. 5. 7.
Did you say 3, 5, 7?
Yes.
1 moment, please. Changes in your stock portfolio at the close of trading today. Amalgamated Widget up 2. You hold 2,000 shares. XYZ Corporation up 1/2. You hold 3,000 shares. Total gains in today's trading, $5,500. Would you like to leave a message for your broker?
Yes.
Start your message at the tone.
Buy 1,000 shares of VOTAN.
Would you like to hear your message?
Yes.
Buy 1,000 shares of VOTAN.
Is this message okay?
Yes.
Your message has been sent. Thank you. Goodbye. Who
Exit.
should I call?
Exit. Exit.
That's pretty impressive.
Yes, it is.
First question I have, that speech is so good, it's hard to believe it's being generated by a computer. Now, what technology do you use to generate this speech?
Well, we use, the general class of technology that we use is the analysis and coding type of technology discussed earlier in the program. And the closest analogy to that is the digital speech that is often used in major telecommunications networks called pulse code modulation, which is 64,000 bits per second. Instead of using 64,000 bits per second of speech, however, we use something closer to 10,000 bits per second. So it is much more cost effective. In fact, it makes it feasible to use that type of speech in a computer system in the context of the costs of disk space and so on.
So you actually have someone speaking in a vocabulary, and you digitize that vocabulary at a sampling rate of around 10,000.
Yes, yes. And then store anywhere from 20 to 100, perhaps 200, or perhaps 1,000, depending on the application, 1,000 of those types of messages at locations or addresses within the computer that are accessible by the computer program.
And you're calling them out a message at a time, and that's why the message sounds like a message.
Yes. Now, you can call it out as a single message if the application calls for it, or you can string 2 or more messages together in sequence. For example, when this application confirmed my identification number as 357, that was really concatenated together, is the term used in the industry.
So we've really had examples of both of the technical approaches to speech synthesis.
Yes.
Can you say a little bit about where do we stand in the state of the art on the recognition side?
Well, there are several dimensions along which that technology can be analyzed. First of all, what I was demonstrating here was speaker-dependent recognition using discrete words. What we have available, and I could have demonstrated it here today if we had prepared for it, is speaker-independent recognition. Speaker-independent recognition is a notably more difficult technology, and one of the consequences of that is you normally have a comparatively more limited vocabulary. The other dimension along which the technology can be evaluated has to do with the distinction between discrete words and continuous words. We also have that available in the lab, and there are a few other vendors in the market supplying that. That allows you to say, instead of 1, 2, 3, 1, 2, 3, without pauses in between. The obvious question that jumps to most people's minds is, how soon will we have continuous speaker-independent recognition? And the answer is not soon. That's a few years out. The third dimension along which it's important to analyze the technology is the dimension of scale of vocabulary. Now, there is a fairly close parallel between the synthesis area in terms of a discrete or individual words pre-programmed, as we shown here, and what was demonstrated earlier by Carl in terms of, in essence, unlimited vocabulary. The technology for doing unlimited vocabulary speech recognition has been worked on for a number of years and is being worked on presently. Both ourselves as well as perhaps a dozen other people are working on that, and that is probably 2 to 4 years away.
Carl, I'd like to get you back in here. Tell us about the applications from your side, from the kind of, like call text, for example, as you showed us.
Well, the primary application of the call text is to access any text database invoice over the telephone. It not only is applicable to retrieving electronic mail messages, but for instance, a salesman in a customer's office can call in over the telephone into the database and retrieve that customer's order status, or perhaps the current inventory of a particular part, so that he knows that the customer can place that order in time.
Okay.
The important concept there is that it doesn't require the intervention of an operator. It saves the cost of an operator.
As your computer told us about 10 minutes ago, we're out of time. Gentlemen, thanks so much for being here, and we'll see you again.